Good evening, everyone, and welcome to this special presentation, Engineering Design and Problem Solving, EID 101, a gateway to Cooper Union's engineering program. I'm Helen Freeman, the Assistant Director for Alumni Affairs at the Cooper Union. Tonight's speakers will include Lisa Shay, Associate Dean for Educational Innovation and Professor of Electrical Engineering, Michelle Rosen, Assistant Professor of Mechanical Engineering, sophomores Sadia Rahman and Vanessa Sen, who are both mechanical engineering students and were mentors this year. First-year students Evelyn King, a mechanical engineer, and Zidane Karim, an electrical engineer. Together, they will give the history of the EID 101 class and insights into how the program builds community among the engineering students and eases the high school to college transition. Tonight's program will be approximately 1 hour. We hope to have time for a Q&A at the end. So if you have any questions for one of the panelists, please submit it into the Q&A feature at the bottom of your screen. And with that, I turn it over to Professor Dr. Lisa Shay. Thank you.
Good evening. And Mike, can you restart my video, please? There we go. Okay. So good evening, ladies and gentlemen, and thank you very much for agreeing to spend an hour this evening with us. I know there are many things that you could be doing with your time, but I really value the Cooper Union alumni community and their engagement with your alma mater. As a college graduate, I know how important it is for me to stay in touch with my alma mater, and I just thank you for deciding to join us this evening. I'm going to start with an overview of the EID 101 course that has been reimagined ever since 2019. Oh, somebody can't hear audio, but I trust that the panelists can hear me, so some people can. So I'm going to start with a presentation showing some of the changes that we've made to the EID 101 course over the last about 6 years since I've been at Cooper. And then I'll have about a 20-minute Q&A with 4 panelists, and then we'll leave some time at the end for questions. So let me start with what I'm calling EID 101 Reimagined. It's a course that's been in existence for many years, long before my tenure here at Cooper, which started in the fall of 2019, but we've made significant changes over the last 6 years. So I'm going to give you a little bit of context for the course, the changes that we've made, and then we'll finish with some discussion from students who have just taken the course in the fall, and one of the faculty members from the course, and some upper class students who have served as mentors in the course. So I arrived in the fall of 2019, and my boss, Dean Barry Shoup, arrived in January of 2019. And one of his first tasks when he got to Cooper was to formulate a strategic plan in consultation with the chairs of each of the 7 departments in the School of Engineering. They spent the spring semester of 2019 working through goals and core values and understanding where the school is and where the school aspires to be. And at the end, drafted this Sustaining a Legacy of Innovation is the title for the strategic plan. You can find it on our website. It was approved in the May 2019 faculty meeting and unanimously approved, which is a pretty miraculous thing in any university. To find all of the faculty unanimous about anything is quite a feat. So we were very pleased that all of the faculty got behind this strategic plan. It has 8 core values, which I'll talk about in a minute, and 7 strategic goals. And Dean Shoup and I really use this as a framework for resource allocation and for decision making. Dean Shoup instituted the Dean's Innovation Grants that year, where faculty and students are welcome to submit proposals that support the strategic plan in some way. It's also a framework for providing faculty professional development and also for student professional development. In the context section of the strategic plan, you can read about the T-shaped engineer, which is a person who is not just, who is certainly very strong in their disciplinary depth, whether it's mechanical, electrical, civil, chemical engineering, but also has a broad ability to work with others, other cultures, to communicate, to be able to work as a team. And so it's both the professional depth in their discipline as well as the breadth in being able to do things that maybe you've heard of as more like soft skills. So when I arrived in the fall of 2019, one of the EID 101 faculty, chemical engineering professor Amanda Simpson, approached me with some ideas about how to improve the course, because this is run across all of the majors. It's run by the dean's office, not any one particular department. And she had taught it for a couple of years and came to me and said, I've got some ideas. I think it's not reaching its full potential as a course. So we had a number of conversations. We realized with this new strategic plan in place, EID 101 could better reflect our core values, particularly respect, integrity, diversity and inclusion, interdisciplinarity, teamwork, social impact, partnership, and better support the strategic goals of student success and educational excellence. And so with that, that next summer, we sent a number of faculty to the Olin Summer Institute. We had put together a proposal, Amanda and I had, to reimagine this EID 101 course. And originally we were going to send 4 faculty, Amanda Simpson, Naveen Shlayan, Mark Luchtenberg, and Cosmas Savelis, one from each of the majors, the ABET accredited majors. And then, of course, COVID happened. And so the Summer Institute became a virtual institute. And for the same price, we could send 7 faculty instead of 4. So we, in addition, sent our STEM director at the time, Dr. Elizabeth Waters, who also had taught an EID 101 section, a mechanical engineering professor, Martin Lawless, and a brand new hire, Dr. Cynthia Lee, who hadn't even started teaching at Cooper yet. She was just hired in 2020 to start that fall, but she was going to be teaching EID 101, and so we wanted her to be part of the process of engaging with what this new course would look like. So we realized that since this course is taught to all engineering faculty or all engineering freshmen, there were multiple sections, and prior to this reimagining, each of the sections kind of operated somewhat independently. And we wanted to have a consistent set of learning outcomes, of course, across all the sections. Those were modeled on ABET's 7 student outcomes that are required for all engineers. We wanted to maintain the focus on design, but also address some of those T-shaped skills. So there's a course-wide ethics workshop. And we had long had our first-year students go through the ESC 000 course, which had a communications module. And so we partnered EID 101 with ESC 000 so that students would go through the communications modules as an EID 101 project team. We're not trying to stifle academic freedom, so each of the sections will have its own theme and its own flavor of projects based on the interests and aptitudes of the faculty. So we're not trying to constrict what faculty can do, but just to provide a kind of a consistent set of learning outcomes for all of our first-year students. And also, especially with 2020 being COVID, we wanted to help our students make that high school to college transition. And so we introduced in each of the EID 101 sections 3 project mentors who provided technical advice for the projects, but also served as role models, both for what Cooper can offer and also just kind of for life questions for students who have moved to a new city for the first time, living on their own. And the EID 101 project mentors can help them become comfortable in this new environment. And that last bit of hiring 9, 12, or even 15 project mentors, depending on the number of students in the first year class, those are paid positions for our students. And we certainly couldn't do that without your support. We had a very generous grant from Mr. Gene Briskman, who enabled us to make that leap into having project mentors for each section. And his donation also helps us provide materials for the EID 101 project so that they can instantiate a physical product if that makes sense in the context of their project. So we absolutely thank our alumni for your help and support in this endeavor. We, being academics, we decided to study, did we do the right thing? How well did it work? And we studied that over the course of the next year. And then again, being academics, what do? We wrote a paper about it, which we presented to the American Society of Engineering Education's National Conference. So it also served as faculty professional development because all of the faculty who taught the course, most of whom had gone to the Olin Summer Workshop, were then co-authors on the paper. And we had a particularly convenient grouping of faculty that year where 4 of the 5 faculty had been to the Olin Summer Institute and used their project mentors in this new way as truly mentors for the students. And we had 1 faculty who sort of served, perhaps a little unintentionally, as the control group of using the EID 101 mentors more as sort of just traditional TAs. And that gave us kind of a comparison group. And as a result, we realized that the sections who had project mentors that were in this new model, those students communicated better and they developed closer bonds with their classmates. So we found it to be a very worthwhile experience, a good investment of time and money. And here is some of the feedback from that first year that the students, the EID 101 students themselves, filled out a survey, and then one of the project mentors did a really nice job of putting them into these word maps. And we have consistently found that the students really do appreciate having project mentors in their EID 101 sections. And so today in EID 101, we have a course-wide syllabus that provides a common framework of course-wide events and course-wide learning objectives for all of the students. They, in the very first week, go on a campus tour. There's a poll where they're allowed to pick the EID 101 section that they spend the rest of the semester in. Initially, they're randomly assigned to one of the sections, but as I had mentioned, each faculty member brings their own passion, their own area of expertise into the classroom. And so the various sections have slightly different focuses in terms of the projects that the EID 101 students will conduct. So they're allowed to select which section they would like to be in. I have a student who runs the resectioning poll, and we're good at least getting the students their second choice, if not their first choice, for what section they get put into. Every EID 101 section has a 2-hour workshop on shop safety because we want to allow them to instantiate their projects, but equipment is dangerous, and we have an obligation to our students and to our institution that our students be safe with equipment. So before they're allowed to use the central shop and the general shop down on the first floor of our new building, they have to go through a 2-hour workshop on shop safety led by those lab technicians, and then they take a quiz, and only once they've passed the quiz are they allowed to use that equipment in the shop. There's also a basically a 3-hour workshop on ethics in engineering. I give a lecture, and then it's followed up with specific discussions that pertain to the kinds of projects that the students are doing in that section. And then, as I mentioned, we partner with ESC 000 to have the communication dynamics workshop. And then at the end of the semester, the students have a showcase, usually the very last week of the fall semester. And for instance, here's the poster from a couple years back. There were different rooms on the first floor, the lobby, and in Gelman Foyer outside of Rose Auditorium. If you've been to our new building, we have a lovely lobby and a lot of space 1 floor down outside of Rose Auditorium that make great showcase spaces. And so each of the projects gets assigned to a room, and for 3 hours, the students stand with their projects, and it's other classes, other faculty, students from other schools, and even some outside guests are invited to tour this end of semester showcase. And I'll show you a few pictures from it. So that's from our foyer. There's a number of projects that are focused on health, and other projects that are focused on improving the environment, reducing pollution, reducing energy usage. One of the things that we're very proud of in EID 101 is that these students choose their own projects, but they've all thought about kind of the bigger picture. They're not just projects for the sake of doing a project, but really taking Peter Cooper's vision to heart of how can engineering make the world a better place. So there was the first picture I showed was a wrist brace for an actual client who needed that. This one about reinventing a wheelchair. There's projects for reducing food waste by measuring spoilage of fruits and vegetables. The students have a great time sometimes demonstrating these, and they get dressed up and get into the part. They're clearly very passionate. I mean, you can just see the intensity in these students as they explain their projects. And this is a view down into Gelman Foyer, where that team that you just saw in the previous picture is demonstrating their project. And so it's a really great opportunity. In addition, the project mentors receive training. We don't just throw them into the mix to just figure it out on their own. The 3 project mentors per section, they receive a total of 5 hours of training and support. We give them 2 hours of training before the semester starts that's really focused on sort of the practicalities of the parts order process, the schedule, the resectioning process, and then a little bit about how to be a good mentor and team leader. And then there's 3 meetings over the course of the semester, roughly once a month, to discuss concerns about what they're seeing in their sections. And we frame it around a book that we read together called Holding the Calm, because in that very first year that we had EID project mentors, the feedback was that they understood how to help freshman students, except when it came to conflict resolution. They didn't have any real training in how to mediate conflicts. And when students are trying to work together on a project and one student just isn't cooperating, what do they do? How do they help? So this book, Holding the Calm, has very practical examples of how to do conflict resolution. They have 18 chapters that cover some very, very useful and practical tools. And so the mentors and I, over the course of the semester, read a few chapters every time, and then we talk about how those techniques can be used in the course. So what did we do this past fall? So the first section was called Bio-Inspired Design. It was led by Professor Michelle Rosen, who you'll get to meet in just a minute. She's one of the panelists. And one of the project mentors is Sadia Rahman, who is on this panel. And one of the students is Evelyn King. And you can see in the picture one of the projects, actually Ev's project, to help make agriculture a little more sustainable, to identify when plants need water so that they don't get overwatered. The second section was called Data Collection and Visualization for New York City Infrastructure. Professor Cynthia Lee, as you saw, she was one of the first faculty to teach in this new section. She was the faculty member for Section B. She's a civil engineer. Zidane Karim was one of the students in her section, and he's one of our panelists today as well. The third section was called Robotics Crash Course. It's taught by Mr. Michael Gillia. He is an adjunct instructor at Cooper. He's also the laboratory technician for both electrical and mechanical engineering. He's half-time in each of the departments. And Vanessa Wu-Sen was a project mentor in his section, and she's on our panel tonight. And then finally, Section D was called Sustainable Urban Infrastructure, Integrating Technology for Resilient Cities. And it was taught by Mr. Benjamin Villa-Weissner, who is an adjunct with an impeccable pedigree. He's such a Cooper faculty person in that regard. His undergraduate degree is in architecture, and he has a master's in design from Harvard, and has really embraced all that we aspire to in EID 101. And so he had some projects focused on combating water pollution with a filtration system, making energy costs lower for people who live in apartments, and also reducing New York City's reliance on fossil fuels with installable solar panels for apartments. So really, it's a totally new type of course since I've been here in Cooper Union. And I'm going to turn it over now to the panelists, and we'll hear from those who have been in the course most recently. Let me stop sharing. Okay. So I'm going to start by asking our panelists, starting first with Professor Rosen. So Professor Rosen, please introduce yourself, what your background is, where your degrees are from, how long you've been at Cooper, and then we'll start asking the students.
Yeah. Hi, everyone. I'm Professor Michelle Rosen. I'm an assistant professor in mechanical engineering. I have a background in mechanical engineering. I have my undergraduate degree from University of Maryland, and my master's and PhD, both from Harvard. I work mostly in bio-inspired robotics, so hence my bio-inspired robotics section. I joined Cooper in 2021. Fall of 2021, and I came from basically being a lecturer at Harvard, where I was teaching a somewhat similar freshman design course. So I hopped right into EID 101.
Thank you. All right. Next, Zidane, would you introduce yourself, please?
Hi everyone, I'm Zidane. As mentioned before, I'm a freshman electrical engineering student, and I think coming into EID, I was very expecting to do a lot of coding and electrical based interfacing. But being in the civil engineering section, section A, I got to experience a lot of what engineering has to offer from the other side, and I think it taught me a lot about how to approach those problems with solutions that don't immediately jump to overblowing budgets and solutions that can be way simpler than anything I imagined.
Thank you. Evelyn.
Hi everyone, I'm Evelyn King. I was in Rosen section for EID 101, which was bio-inspired design, and I'm a freshman mechanical engineer.
Thank you. Sadia, please.
Hi everyone, my name is Sadia Rahman. I'm a sophomore mechanical engineer. I was in Professor Rosen's section in my freshman year, so bio-inspired, and then I became the project mentor for her section this year.
Thank you. And last but certainly not least, Vanessa.
Hi everyone, my name is Vanessa. I'm a second year mechanical engineering student, and I was a student and then project mentor for the robotics section, which I'm very excited to share about.
Thank you. Thank you. So, I see there's a question in chat. So what is the overall objective of the course? This is a first year required course for all engineers, and it's really to give them an introduction to the engineering design process, to allow them to design a process or a product from start to finish, but of course constrained so that it can be done in one semester. But in addition to that, all of the ABET student outcomes of solving complex engineering problems, applying math and science, communicating their decisions, making ethical decisions in regards to engineering design, designing in a constrained environment, all go into the process. So Professor Rosen, if we could turn to you now, what do you find most rewarding about teaching EID 101? Because you've been doing it for a number of years.
Yeah, so I always kind of come back to the most rewarding thing being seeing the students succeed. So when they come in, a lot of them are somewhat scared. They don't know what engineering is. They don't know how to do engineering. They can't do this. They think it's going to be, their project's going to turn out terrible. And it's always amazing to see them work through the process together and amaze themselves at the end, and me often, like, I'm very amazed by what they can do. Their creativity, like, I mean, I've been doing this for a while, and sometimes it's pretty easy to get jaded about ideas and you shut down your own ideas before you even say them. And it's really great to get, some of the new blood, kind of injected in there where they don't necessarily have some of those constraints, and you see some real creativity come out in their approaches to projects. And just, seeing them be so excited when what they were trying to do actually works, and, working through when it doesn't work as well. So that's always what I find the absolute most rewarding part.
Thank you. Thank you so much. So Sadia, you mentioned you were in Professor Rosen's section, and then you were a mentor. Why did you choose to be an EID 101 mentor?
I chose to be an EID 101 mentor because in my freshman year, my group was having particular problems within our dynamics, and our project mentors were always there to help us out. And we also created a project that we thought was probably not going to work. And the satisfaction that we all felt, I just wanted to bring that forward to like the incoming freshmen so that they really feel excited about engineering and be like a helping or a guide for them throughout their freshman year and a resource to them even after EID 101.
Wow, thank you. Vanessa, the same question, because you're a mentor for the same section that you were in last year, right?
Yes, that's right.
So why did you become a mentor?
Yes, well, first of all, EID 101 was the class that I considered the most fun the first semester that I came into Cooper. And a big reason for that was the project mentors. Whenever they hosted office hours or whenever they were there to help us, it felt really welcoming, and we were able to see them as more than project mentors, even as friends later on. And I wanted to be this person that could do this for the freshmen, the incoming freshmen, able to give them a good first impression of Cooper as well, and show them that here we're a very tight-knit community and we're always willing to help each other. And I found it super rewarding. I found that I was able to build connections with the freshmen and also learn a lot from them, because even though I'm 1 or 2 years older than them, I find that they always surprise me with all their ideas, and there's a lot to learn.
I find that as a faculty member as well. I learn from my students, and I've been a faculty member at various places for more than 20 years, and I still learn from y'all because Cooper students are pretty amazing. So you've kept in touch with some of your students from last fall?
Yes, definitely. I love it whenever I see them on the hallway, they'll just come up to me and talk about classes, professors, and even if they need help, sometimes they text me as well. And I'm always willing to help them. Yeah.
Very cool. And that's teamwork is one of our core values and one of the things that we aspire to improve in our students, and our mentors absolutely demonstrate that. And we thank you for that. So turning now to the first year students, Evelyn, what project did your team come up with, and how did y'all figure out that was what you wanted to do?
Yeah, so we were the reinventing the wheelchair project that you had a picture of earlier. Um, we kind of actually struggled to settle on a design for a very long time because it was six of us and we all had very differing interests. And so finding something that was like rewarding and interesting to every person of the group was a bit of a challenge. But we finally came to wheelchair design because there were a couple people in my group who were very interested in kind of like car design or tank design, like more moving things, and just vehicle design. And there are a couple of people who are very interested in like directly helping a certain group of people. And then like me, I'm very interested in disability creation and trying to make it easier for people with physical disabilities to live their lives to their fullest extent. And so we settled on trying to create a new form of a wheelchair, or we ended up doing a new form of the actual wheel of a wheelchair to be able to get around a city environment easier and more independently for a wheelchair user.
So did you have conflict at the beginning that you needed help working through to settle on this project, or did it all kind of come together pretty smoothly?
There was a little bit of conflict that we definitely ended up going to Sadia for. Sadia was our TA. So, but we it was very helpful to have someone who had kind of gone through the same sort of issues and had insight, like at the end of it, of it's worth it to work it out because you'll end up making something that much better. But yeah.
And how did you sort out roles in your project? Like, were there defined roles that somebody was a lead design, somebody was on documentation, or how did you sort that out in the project?
It was kind of just like focusing on who's interested in what. As for documentation, is like nobody really super wanted to do it, so we all kind of just switched off on it. But for like the actual design aspect, there were a couple of us who were really interested in making the molds because we ended up making like very small scale, like maybe this big wheels for the end of the semester. And we made them out of silicon and 3D printed molds that we like ended up pouring the silicon into. And so some of us were very interested in that. There were a couple other people that were much more interested in like displaying all of our research and working on the paper for the end of the semester and working on our poster presentation for the end of the semester. And there was one or two people that were very interested in the like testing apparatus for our wheels. So they ended up working on a lot of coding and more electrical systems to figure out which design actually ended up being the most useful.
So you had a whole, not only did you design it, but you had some criteria and you tested the design against those criteria.
Yeah, we ended up testing against essentially how much force is required to use a certain wheelchair from rest, like a wheelchair wheel pattern, and then whether or not it would slip if it was wet outside, both very important things. And then if it could get over a certain vertical distance, so like getting up onto a curb from a wheelchair. Those were kind of our three criteria. And we ended up making a testing apparatus that was basically it measured voltage drop for you to be able to go over a certain texture that was sort of mimicking different urban environments. And that voltage drop, it corresponds to essentially the required amount of force to be able to actually go through that, like if you were pushing a wheelchair. So it was very interesting, and the entire project taught me so much more than I was expecting to learn my first semester on like realistic engineering stuff. I was kind of expecting, like, a lot of my friends and my family before me have been engineers, and a lot of them are like, yeah, no, the first semester year is kind of just work, grindstone, like math, science, no actual design. And so I was very excited to actually be able to learn, like, this is how you write a paper, and this is how you do a presentation, and this is how you actually present your ideas.
And were all the students in your group mechanical engineers?
No, we had, oh no, we had, it was me and one other person was a mechanical engineer, and then we had, or no, there were three mechanical engineers, one chemical engineer, and two electrical engineers.
Very cool. Thank you. Awesome.
There's one question. Yes,
Did your
we
team
did.
test existing wheelchairs?
We did. We made a mold for the kind of standard pattern of wheelchair wheels, which was actually much easier than the bio-inspired ones, um, because it's very geometric, and bio-inspiration is rarely geometric. But yes, we tested that as our baseline, and two of our three bio-inspired designs ended up testing better, and the third one did not. The three we did were like the skin of sharks, the skin of snails, and the skin of snakes. And we basically just mimicked the pattern that their skin or scales naturally form, to see which could provide the best grip, essentially.
Cool. Thank you. So turning to you, Zidane, what project did you work on, and how did your team decide upon that project?
So Professor Lee early on in this semester gave us this assignment where we broke off into groups. These weren't our project groups yet, but she split us into sections where we would go outside, like leave the classroom and explore the area around Cooper, and we would make note of certain data points, like things that are observable, things about the environment around us. So we focused on parks for my section, but other groups were looking at subway stations or things like public conditions. And it all inspired us to start thinking for our projects about measurable data. Um, so when we were considering our idea, when we finally formed our groups, we were thinking about what could we look at that has measurable data that we can deliberate on, and also what relates to our shared experiences, because we could then combine factual information with our own lives, which I think drives like a real passion-driven project. And we were all NYC natives, so we decided to focus on the subway system, specifically the thing that gripes us about the subway systems, which was subway delays, because we noticed that everyone who, well, not to speak for such a general population, but most people who experience subway delays are mostly uninformed on the causes of these delays, and that's not entirely their fault. It's because the information that is released is not 100% accurate, and there's a broad category of ethical issues that goes into that reasoning. But my group decided to put together a game so that our audience would enjoy playing and looking through our simulation, a game that would mimic a typical subway run while experiencing those delays and then educating as to why those delays happen and how those reasons are hidden from the public.
Wow, that's fascinating. How many students were on your project team?
So we had three electrical engineers, one civil engineer, and one chemical engineer. So five total.
Five total. And I think I see the question in chat. That's 5 or 6 is fairly typical. We tend to have about 30 students in an EID 101 section. And then we have the number of sections needed to cover the freshman class. So this year there were 4 sections of about 30 students and a a faculty member has has a span of control of only so many projects. So they typically have a few 4 or 5 projects in their section. And so then you just do the math. If there's 30 students and 5 projects, then you get 6 students per project. I guess, although I guess, I really shouldn't be speaking to that. Professor Rosen, what's your philosophy on how big a project team should be?
So I actually tried something my first year, which was somebody told me, oh, there's 3 projects per class. So I took my section of 30 students and divided them into 3 groups. So groups of 10. It didn't go that great as far as having enough work for everybody to do and, being able to divide it up, making something that's challenging enough for 10 people that, 3 people aren't just sitting off to the side. So my philosophy is generally I find the sweet spot to be somewhere between 4 and 6. I tend to err on the side of just 5 to 6 students, just by the way, the numbers that we've had. And because I purposely try to balance teams, I make all my students fill out a survey, basically answering a little bit about themselves, what their skills are. And then I try to kind of balance it out so I don't have all the mechanical engineers on this team who are, good at CAD, and then all the electrical engineers over here are good at circuits. And then when the mechanical engineering team comes to something that they need to build a circuit, they're very stuck. Right. So I try to kind of balance it and make sure that because everybody comes in with a very different level of background, right? Some students have been on their robotics team for the last 4 years, and some students decided they wanted to be an engineer right before they went into college, right? And don't have too much practical experience. And I try to kind of get everybody on that level playing field by mixing up the groups. So I find 5 to 6 is usually I'm usually able to get a good mix with that team size.
Thank you. And I've done some studies. As I say, I've been a faculty member for more than 20 years, and I've run a capstone course in another institution. And it's useful to have at least 2 people from the same major on a project team, because then they can help each other out. If you just get a single student, they become the sole expert on, say, EE. But especially in their first year, they're not an electrical engineer. They're a high school student with 2 weeks of college under their belt. So it's better to have at least 2 students of a given major, if possible, on a team. And so then you get, naturally 4 to 6 students on a team from 2 or 3 different majors. So we're coming close to the end of our panel discussion part. So I'd like, Professor Rosen, you just do a little retrospective for us. You've been here for 4 years. You've taught EID 101 for all 4 years. The seniors who just graduated, you taught EID 101 in. So now you've seen from soup to nuts, A to Z. What is your impression of the enduring skills that EID 101 provides your students now that you've seen them throughout the curriculum?
I also teach senior design, so I actually do get to see both ends, which is fantastic. I think really what EID 101 does really incredibly well is focusing a lot on the problem and not so much the solution, which is something that's really hard for all of us. Like I tell my students, we're all human, and especially engineers, when we see a problem, we want to fix it, right? Like that's immediately what we want to jump to. And, I constantly say it, and I love when students say, oh, what Professor Rosen would say when they don't even think I'm listening, which is like, problem, not solution. My students in design and prototyping right now know that too. Right, problem, not solution. And so that's something that I think really carries over into senior year, right? It's not something that is as heavily emphasized in sort of the in-between. I'd say there are a couple classes that touch on it, but we all know, sophomore to junior year, a lot of it is very technical. Even if there's a design project, it's usually, somewhat structured and scaffolded before it's, given to you. I think what EID 101 and senior design both have is this sort of open-endedness, where it's really up to the students to pick their own projects. whatever that looks like. And I think those skills of learning how to do that is something that hopefully carries with them throughout their time at Cooper. I also think we do put a little bit more emphasis on teamwork and some of the quote unquote softer skills, right? In EID 101, which sometimes gets some complaints, documentation and, writing and presenting and teamwork and all those things that, a lot of times when you get to later classes, it's just assumed you know how to do it, right? You know how to work on a team, right? And so I think, actually taking the time to have that kind of discussion and instruction in EID 101 instead of just assuming everybody knows how to do it, really kind of helps throughout the next few years.
Very cool. Thank you. And then turning to our student mentors, now that you've had EID 101 behind you by 3 semesters, what have you gotten? What enduring skills do you see that you've gotten from the course? So, Vanessa, we'll start with you this time since we started with Sadia before.
Yes. So we definitely learned a lot in EID 101. And for Sadia and I, as mechanical engineering students, we have had principles of design and now design and prototyping with Professor Rosen. So a lot of the skills we learned in EID 101, we're definitely using them right now. And one of the main things also is how to communicate our ideas as engineering students. Sometimes we're talking about circuits or a design, and we have to make sketches and we have to be able to present them correctly so the public can understand us. And also just going up in front of a crowd and giving a presentation on a project that we're passionate about. That practice in EID 101 really helps in these classes now. And for my section specifically, we learn how to use a Gantt chart, how to make state machines, make a bill of materials, and even something as easy as a problem definition is actually harder than we think. So going through that exercise was really helpful. And beyond that, learning how to use the lab spaces at Cooper, so the machine shops downstairs or the makerspace lab, and knowing all the safety procedures that we need to be able to use those resources.
Very cool. Thank you. And Sadia?
I agree with Vanessa, especially right now in DAP. We're just wrapping up on our project that was pretty similar to EID 101, where we designed an educational toy based on what we thought was educational, and we provided a solution which was so similar to EID 101. And I was so glad that I had all the skills that I learned under my belt and also the skills that I picked up as a project mentor. It really did help in working in a smaller group. And outside of coursework, it has been helping with my other projects that I have taken on at Cooper and like keeping up with documentation and figuring out prototypes where we definitely do not have any basis for, as well as understanding how to incorporate background research and incorporate it into our solutions or like use it as a way to measure our solutions. So overall, EID 101 has been sticking with me in like all my courses in one way or another.
Thank you. Thank you very much. All right. So we're now at the point where we're here to take questions from all of you. Just looking through the chat. There was a question about the overall objective of the EID course, and EID is an interdisciplinary engineering design. That's the EID prefix as opposed to an ECE or a CE or a CHE course. And so it really is the design process and the design implementation along with all of the other skills that it takes to be a good engineer. And I don't know what there was before EID 101. This course has been on the books for many years. It's just that we in 2019 started updating it to be the course that I've talked about. How do you manage students who don't really contribute? So Sadia, what do you say to that? You've been a project mentor. How do you manage students who don't contribute?
So this year, my group, which was Evelyn's group, they had quite a little bit of difficulty in like working with each other and like certain people not stepping up or certain people doing too much. And how I handled that was at first we tried to have them discuss amongst themselves and see if they could set little criteria for each individual to meet. We saw that that didn't work out too well. So I took them all outside and I gave each person 2 minutes to let out what they felt was not working with the group or what they themselves felt that they weren't doing for the group. And that kind of opened up their mindset to what others were thinking and what they themselves really wanted to express to their group. And that in turn helped them understand each other a little better and understand the goal that they all were trying to achieve. And they started to work a little better. They got into more smaller subsystems for their project and learned how to communicate with each other. And they came up with their amazing project.
Very cool. Thank you. And I think, oh, and then there was a question about how do you handle mentors on complex issues like ethics? And Vanessa, I'd like to turn that to you because certainly robotics has your particular project were autonomous small robotic vehicles. And so did you talk about like the ethics of autonomous vehicles or the ethics of AI in vehicles in your section at all?
We didn't dive into it too much, but we definitely mentioned that to the students. We talked about it briefly, and they also had their freshman year seminars where they cover a lot of ethics, and they talked to us a lot about that, how they enjoy these seminars. And ethics is definitely becoming a more important topic nowadays. And we try to give them all the resources we could if they wanted to talk about the use of AI or what they felt the project was important to them or if they felt the project was not relevant at all and such.
Thank you. And I'd just like to put in a plug, the ESC 000 seminar, the professional development seminar in the spring does something that I don't know of any other school doing. We have, for the last 3-4 years, had an interactive play in the spring semester where the stage crew would stop at various points and an ethical question would be raised, and the students in the audience would then divide into groups of 4 or 5 and vote on what would happen, what decision that character would make. And then after their discussion, they vote, we tally the votes, and the play's plot will actually shift depending on the votes that come out of the student discussions. And so the first 2 years that we did it, this was one of the Dean's Innovation Grants. We had the late Professor Daniel Lepic sponsor a reading of the, oh, now I'm drawing a blank. Ibsen's play, and I'm drawing a blank on it. I'll have to look it up.
Gabler, Doll's House.
No, it was the gosh, there's a small town whose drinking water was polluted by lead, and the play was actually set in America because it was an adaptation, and the mayor and the mayor's sister, who is an environmental engineer, were now on opposite sides when the hot springs that were providing revenue to the town were found to be contaminated with lead. And now the town's economic livelihood was at stake, but then also public health was at stake. And then there was a question, how bad of a lead issue is it? And so at various points in the play, the students would decide, should the environmental engineer do X or do Y? Should the mayor do X or do Y? And then the play would unfold. And then last year in this, we had a small theater troupe called Italia Theater develop a modern adaptation of Rossum's Universal Robots called Rossum's Universal AI, where
it's someone from the chat remembered the name of the play, Enemy of the People.
Enemy of the People. That is it. Yes, thank you.
Which I think was on Broadway within the last year or so. So that's great. Thank you.
Yeah. So anyway, so that was so now we have an adaptation of Rossum's Universal Robots. And again, at various points in the play, the students vote on what a character does. And so it brings ethics into a situation that feels more real than perhaps a case study does. Ms. Freeman, you were monitoring, there's a Q&A site somewhere. Are there other questions?
There are a couple of questions in the Q&A. So I think, let me just start from the top. So Rick Andrews, who's a member of the class of 79, said that EID 100 was his favorite class their freshman year. And they noted that women were a small minority in their class. So I think noticing the makeup at the panel, they were asking specifically what the percentage of students and faculty are who are women currently, if we know that.
Oh, great. Yes. A lot more than there was recently. So when Barry Shoup and I came, the faculty were about 14% women. And that was before Professor Rosen was hired, Professor Lee was hired. Now it's 42% women in the School of Engineering. And one of the recent freshman classes was actually 50% women. And let me see. The School of Engineering right now is 38% women, but it does vary a lot by major. Chemical engineering is almost 50-50. Electrical is 28% women. I'm an electrical engineer myself, and I can attest it's generally not very many women in electrical engineering.
Someone in the chat noted in 1966 there were 2 women.
Okay, yeah, so it was about 2%.
I don't know if that's faculty or the entirety of the student. Anyway, fascinating. I think, Professor Rosen, you sort of touched on this, but someone is asking, do the teams select their own members or are they randomly assembled? I think your answer said it was somewhere in between, but if you could clarify that.
Yeah, so in my section, I do assign them, but it's not like a random assignment. Like it's very purposeful in trying to balance those skill sets, balance those majors, make sure, as Dean Shay was saying, nobody sort of stands alone. Either that includes majors and women, right? I don't like to have just one woman on a team, right? Because then they become sort of the one. So I do try to kind of group things up in that way. So they are assigned, but thoughtfully. I'm not sure exactly how it's done in other sections. Maybe Vanessa or Zidane can talk to that. But I believe most of them are usually assigned because otherwise you do get, kind of teams of varying strengths and that sort of thing. And I think the whole purpose of EID 101, it's in the EID, right? That interdisciplinarity where we are really trying to reach across those disciplinary lines in a class like this.
Well, so Vanessa, how were teams assigned in your section?
Yes, so for our robotics section, since we had 3 main components for building the line following robot, we asked the students to fill out a form where they rated their skills on coding or electrical design or mechanical design, sorry. And from that, we did base off to make a balanced team. And same as Professor Rosen's section, we did try to put at least two women in one team so that they wouldn't feel alone. And we were able to do that. And apart from that, we also asked the students if they wanted to work with someone else specifically. And if both students put the same person, then we will try to match them up as best as we could.
Very cool. Thank you. Yes, it's a good point also about the number of women. You don't want to have just a single woman on a team or they become the spokesperson. Zidane, was that kind of your experience too in Professor Lee's section?
So our section was mostly paired up on interest, on what we wanted to work on. Like I mentioned before, we had interest on the subway. So we noted that in our survey form, like what did we want to focus on for infrastructure?
Cool.
So I think we have time for one last question. So this person is saying it's fantastic that this course gives students an early practice with holistic design and applying engineering to solve real problems. Are there any other courses besides senior design that offer similar or complementary experiences?
So in terms of being interdisciplinary like that, not too many because the students will pretty much track into their majors, but there are certainly project-based courses at all levels in all majors. Professor Rosen, do you want to elaborate more
Yeah,
for mechanical?
I can speak for mechanical, but I also want to give a plug for the VIP courses here too,
Oh, right,
which
of
is the
course.
vertically integrated projects. So those very much are all, as far as I can see, solving real world problems. So for instance, I run the VIP course on building a CubeSat. So building a small satellite to go into space, very interdisciplinary, very kind of open-ended, like, yes, there is a goal, but what is our science mission? What are we doing with that? That sort of thing. So those are very much complementary. On the mechanical side, yeah, there's a lot of sort of design classes through the curriculum in mechanical. So EID 103, design and prototyping, which I'm currently teaching. In my courses, I generally try to loop in some kind of open-ended project, whether it's dynamics or mechanics and materials. I try to do that a little bit, but we also have an experimentation course junior year where students do build an experimental apparatus, usually based on they have an actual client. So like I've been the client where I'm like, I would really love a torsion testing rig to be used in mechanics and materials. And so the students address that.
Thank you.
All right, so on that note, thank you. I want to thank everyone for attending this evening. A huge thank you to Dr. Shay, Dr. Rosen, Sadia, Vanessa, Ev, and Zidane for your time and insights this evening. I found it fascinating to learn more about the engineering program and this unique introductory course. I also want to thank the donors for the program, especially Jean and Susan Briskman. I wouldn't be doing my job fully if I didn't make sure you're aware of opportunities to donate to the Cooper Union. You can learn more by visiting our website, which is cooper.edu/giving. Thank you. Thank you, and have a good night, everyone.